This is the first word problem, and it's asking us to convert a temperature from Celsius to Fahrenheit. And it's telling us that in order to do so, you take the temperature that's in Celsius, multiply it by 1.8, and then add 32 to the result. And that is going to give us our Fahrenheit. So let's just see what it's telling us. Okay, so it says take my temperature in Celsius, multiply it by 1.8, add 32, and then that's going to give us our Fahrenheit. Well, I think we've kind of got our formula right there. It's our Fahrenheit is equal to 1.8 Celsius plus 32. Let's do a little check. So the temperature at which water freezes, I'll go Celsius here and Fahrenheit here. Water freezes at Celsius at 0 degrees, and in Fahrenheit at 32 degrees. And water boils at Celsius at the temperature of 100, and in Fahrenheit at 212. It seems to me that Celsius makes a lot more sense than Fahrenheit. I don't know why we don't use it, but we don't. So if I kind of test this now into my formula, if I have my C is 0, then 1.8 times 0 is 0. That leaves me with 32, and sure enough, my Fahrenheit is 32 degrees. So that works out for the temperature that water freezes at. And if I plug in 100 for my Celsius, so I'd have Celsius 100 times 1.8, so 100 times 1.8 is equal to 180. I add 32, I get 212. So, same-o, same-o. From a mathematical standpoint and checking out data that we're totally confident of, it works. But to take this just a tiny step further, I made a little graph here. And I said, I plotted the point, my x-axis is Celsius, my y-axis is Fahrenheit, and I plotted the point 0, 32, so that's 0 Celsius, 32 Fahrenheit to represent the temperature at which water freezes. And I plotted the point 100, 212 to represent the point at which water boils. And if I wanted to, I could draw a line through those 2 points, the linear function, and we could then predict the temperature from Celsius to Fahrenheit for any temperature that we wanted to. But what I wanted to show you here was the equation. So if I want to look at this line, first I want to find the equation of the line. I'm going to calculate slope. So I'm going to have delta y over delta x, which is going to be y2 minus y1 over x2 minus x1. So my y2 I'm going to use as 212, and I'm going to use my y1 as 32. And then I'm going to put that over my x2 at 100 and my x1 at 0. So that gives me 180 divided by 100, which, not surprisingly, is 1.8, the slope of the line, and, as we determined up here, the slope in the formula. Well, if I have 1.8 as my slope, and I have a point, why don't I kind of use the point slope and just see how this works out? So I'm going to use the easier point of 0, 32. So I'm going to have my y minus 32 is equal to 1.8 times x minus 0, my point slope form. So y minus 32 is equal to 1.8 because x minus 0 is x. I'll add 32 to both sides. I get y, oh, I'm sorry, 1.8x. I get y is equal to 1.8x plus 32, and my y was my Fahrenheit, my x was my Celsius. So you can see kind of the relationship between doing this graphically and up here doing it as an equation.